All right, welcome class. Today we are going over 3-5. We are determining the number of solutions. Our learning intentions today is to be able to predict the number of solutions to an equation. And we know we got it when we can combine like terms, use inverse operations, and distribute to determine the number of solutions to an equation. Let's see what that looks like and get into it right now. All right, so we know that an equation will have one solution when we end up with the answer, our variable, in this case x, right, will equal a number. So for this, I just put a. So when you have x equaling a number, or y, or whatever variable you have, equaling a single number, well, you have one solution, and your solution is the number you have found. So let's take a look at what that looks like over here, right? The opposite of multiplying by 2 is dividing by 2. This will cancel, go to 1. We will be left with x equals 20 divided by 2 is 10. So our answer is 10, right? Let's take a look and make sure on the next slide that we did our work right. I'm pretty sure we did. This is easy, but let's double check. So as you can see, I'm going to put the work back up here for you guys. When you divide by 2, you'll get x equals 10. So x is 10. You have one solution. That one solution is 10. That's how that's going to work. So it doesn't matter what equation you have. When you solve it and you get to the end, if your variable equals a single number, you have one solution, and your solution is the number you have found. In this case, 10. All right, let's go take a look at the next case. So our second case is going to be 0 solutions. There are no numbers that will make this equation true. It has 0 solutions. And you will get that when you get a number equals another number. So for instance, right, 7 equals 9. That is not true. That will never be true. 7 doesn't equal 9, so there are no solutions. Let's take a look at our example here. So we have to subtract 3 from both sides to get our like terms together. Those will cancel. We will be left with 4 equals 0. Well, 4 does not equal 0. 4 will never equal 0. So there are 0 solutions to this equation. This equation has no solutions. Let's go to the next slide. This will all be nice and pretty, and we can see if we were right. So, like I just said, 4 doesn't equal 0. It never will equal 0. So there is no solutions. So let's go take a look at the last case, our infinite solution case. All right, so we will have infinite solutions. All real numbers are solutions. Both of those mean the same thing. When you have a number equals the same number, for instance, 3 equals 3. Well, yeah, that is true. That will always be true. There is nothing you can do to make 3 not equal 3, so that is infinite solutions. Let's take a look at this example problem and see if we can get infinite solutions from this. So let's subtract 4 from both sides. Those will cancel. Let's subtract 3 from both sides. Those will cancel. And it looks like we're going to be left with 0 equals 0, which is a factual statement and will always be a factual statement. So there is nothing I can do to this equation to make it not true, right? To make it false. So all real numbers are a solution to this equation. It has infinite solutions. They clearly didn't take it as far as I did. So yeah, you could actually stop as soon as you got rid of your variables, right? You would be left with 4 equals 4. That is also a factual statement that will always be true. So like I said, nothing you can do to this equation to make it wrong. All right, so this is infinite solutions. Next, we're going to look at a table that can help us find our answers a little quicker, maybe. All right, just kidding. Before we get to the table, we actually have an example. So let's find out how many solutions this equation has. So out of the gate, we can't tell yet, right? We have to solve this problem a little more before we can see how many solutions we have. So first things first, distribute. Outside times inside. 3 times 6 is 18. 3 times 4 is 12, so that gives us a negative 12g equals Negative 2 times 6 is negative 12g again. Right there, that should be a hint. We kind of have an idea of what's going on. Negative 2 times negative 9 is plus 18. So at this point, you're going to want to combine your variables. Opposite of minus 12 is plus 12. Plus 12. Well, our variables cancel on both sides. We are left with the statement 18 equals 18. Well, that's a true statement. That will always be a true statement. So there is no value you can plug in for G to make this false, which means infinite solutions, all real numbers. Next couple of slides are just going to be this work, but in a more clear fashion. So pause it if you need to copy it at any point. So this should be your equation after your distribution, at which point you would combine your variables. When you combine your variables, you should once again get 18 equals 18, meaning infinite solutions. All right, so this is the table I really want you to copy down because it kind of helps you identify where you are before you even finish the problem, right? So if you have an equation and your coefficients are the same, meaning the number attached to your variables, 6x and 6x, but your constants are different, 3 and 1, you will have no solutions. If your coefficients, the number in front of the variables, are different, 6x, 4x, and you have different or the same constants, your constants don't matter. So really all that matters, if your coefficients are different, you will have one solution, right? If your coefficients are the same and your constants are the same, well, you will have infinite solutions. So to repeat and to summarize, if you have different coefficients, you immediately have one solution. No ifs, ands, or buts. If you have the same coefficients, meaning your variables have the same numbers in front of them, you need to look at your constants. If your constants are different, no solution. If your constants are the same, infinite solutions. All right, this should help you answer these questions a little quicker. I want to make a note though, if you have one solution, you can't just stop and say one solution. You have to continue the problem to find the one solution. All right, so this is the end of the notes. This is your check problem. I want you guys to try to simplify this problem and get it to a point where you can determine the number of solutions. Remember, if there is one solution, you have to take the problem the entire way and tell me what that one solution is. All right, pause it here, try to answer the question. Answer is going to be on the next slide. So if you crunch the numbers, you should end up with a true statement that will always be true, and you will get infinitely many solutions. Let's see, can we crunch the numbers on this real quick? Can I do this for you real quick, just to maybe show you? 6, distribute that. 6 times x is 6x. 6 times 3 is 18 plus 10. We don't distribute to the 10 because it's outside the parentheses. 2 times 3x, 6x. 2 times negative 4, negative 8. All right, I'm going to combine our like terms here. Negative 18 plus 10 is going to give us a negative 8. 6x minus 8 equals 6x minus 8. Well, if you have your table out that you just took, you could stop right here, right? You have the same coefficients and you have the same constants. That means infinite solutions. If you didn't write your table down or that method doesn't really help you and you're like, I'd prefer to work it out, get rid of your coefficients with your variables now, right? Opposite of adding 6, positive 6 is minus 6. Those will cancel. You are left with, I'm going to write it over here, negative 8 equals negative 8. Well, that's a true statement. That will always be a true statement. Infinite solutions. So even if you can't use that table to shortcut your problem and tell me the number of solutions, you should be able to work through the entirety of it and get your answer. All right, have a good day. Study for your quiz on Thursday. We will do practice for 3-5 on Monday of next week.